I am the virtual teacher at Egnatia Career College. Today we'll teach framing openings in walls, roof construction terms, roof trusses, common rafters, hip and valley framing. This is video number 5. Framing openings in walls. After completing this unit, you will be able to perform the following tasks. Describe typical rough openings. Locate and interpret specific information for framing openings. 2 types of dimensions must be known before window and door openings can be framed: location and size. Opening locations are given by dimensioning to their center lines in a string of dimensions outside the floor plan. Such dimensions are usually given from the face of the studs. 1/2 the rough opening is then allowed on each side of the center line. Dimensions of rough openings. The size of the rough opening, RO, or opening in the framing, is listed on the door and window manufacturer's specifications. Door and window schedules are lists of all doors and windows in the house, usually with nominal dimensions. Doors and windows are identified on the floor plan by a mark, a letter, or number. All doors or windows of a certain size and type have the same mark. Each mark is listed on the schedule with the information for the doors or windows of that type and size. The rough opening dimensions are not usually given on the drawings. They should be obtained from the manufacturer. Window manufacturers do not list the same size information in their literature, but they do list the rough opening size. Other sizes they sometimes list are nominal size or unit dimensions, approximate overall size of the window, and glass size, size of the actual glass in the window. If the finished doorway, the jamb, is to be built on the site by a carpenter, the rough opening size will not be available. In this case, the rough opening for swing doors can be built 2 inches wider and 2 inches higher than the door. If the door is another type, you must first determine what the finished opening is to be. Manufacturers of hardware for sliding and bifold doors specify rough opening sizes for doors installed with their hardware. These manufacturers' specifications should be consulted as the opening is being framed. Sizes of doors and windows are given with the width first and height second. To further simplify dimensioning, they are often listed as feet/inches. For example, a 2.6 by 6.8 door is 2 feet, 6 inches wide by 6 feet, 8 inches high. Framing openings. In stud wall construction, it is usually necessary to cut off or completely eliminate one or more studs where windows and doors are installed. The load normally carried by these studs must be transferred to the sides of the opening. The construction over an opening that transfers this load to the sides of the opening is called the header. Additional studs are installed at the sides to carry this load. A set of construction drawings includes details showing the type of rough opening construction intended. It has been conventional to build headers in exterior walls with 2 by 10 or 2 by 12 and plywood spacers between to form the header. A flat 2 by 4 may be nailed to the bottom of the header to reduce the height of the top of the opening, but this flat 2 by 4 is filler and not a structural part of the header. Following advanced framing techniques, the header may be a single 2 by installed flush with the exterior surface of the wall framing. The decision to use a single ply header must be made by an engineer, considering the loads that will be imposed on the header. The framing around the opening can sometimes be further simplified by replacing the jack studs with steel header hangers. To conserve lumber in non-bearing walls, the header may be 2 by 4. The area over the header is framed with cripple studs. The area below a window also is framed with cripple studs. These cripple studs are installed on the normal spacing for wall studs. This may require a cripple within a few inches of a side jack stud, but is necessary to provide a nailing surface for the sheathing. Pocket doors are sliding doors that slide into an opening in the wall, thereby allowing the largest possible opening without swinging into the room. Most builders install pocket doors as a pre-assembled frame. The wall framing to provide the opening into which a pocket door assembly can be installed is generally the same as the framing for any other type of door. Pocket door manufacturers provide rough opening dimensions for their products. Several systems of metal framing are available for light construction. The basic elements of light gauge metal framing are the same as for wood framing. These systems use top and bottom wall plates, studs, and floor joists. To make light gauge framing compatible with wood, the metal members are made in common sizes for wood framing. The greatest difference is that metal framing is joined with screws instead of nails. Headers over openings in light gauge metal framing are usually very similar to those in wood framing. However, the system designed by the metal framing manufacturer should always be followed. The APA, the Engineered Wood Association, publishes several design and construction guides on a variety of topics suggesting ways to use wood products more efficiently and to make structures more durable. Most of these guides are fairly recent, so the techniques described in them have not been adopted by all designers and builders. Anyone in a position to make decisions about construction techniques would do well to become familiar with these and other modern construction developments. Roof construction terms. After completing this unit, you will be able to perform the following tasks. Identify common roof types. Define the terms used to lay out and construct a roof. State roof pitches as a ratio of rise to run or as a fraction. Types of roofs. Several types of roofs are commonly used in residential construction. Variations of these roof types may be used to create certain architectural styles. The gable roof is one of the most common types used on houses. The gable roof consists of two sloping sides that meet at the ridge. The triangle formed at the ends of the house between the top plates of the wall and roof is called the gable. The gambrel roof is similar to the gable roof. On this roof, the sides slope very steeply from the walls to a point about halfway up the roof. Above this point, they have a more gradual slope. The hip roof slopes on all four sides. The hip roof has no exposed wall above the top plates. This means that all four sides of the house are equally protected from the weather. The mansard roof is similar to the hip roof, except the lower half of the roof has a very steep slope and the top half is more gradual. It is also similar to a hip roof in that the roof slopes on all four sides. The shed roof is a simple sloped roof with no ridge. A shed roof is much like one side of a gable roof. This type of roof is used in modern architecture and for additions to existing buildings. Roof construction terms. The roof construction terms used with trussed roofs, the most common type of roof framing for light construction, are defined below. Top chord is the top member in the truss. Bottom chord is the bottom member of the truss and acts as a ceiling joist for the space below. A web member is any of the interior bracing between the top chord and the bottom chord. A gusset is a reinforcing piece of metal or plywood fastened to the truss, where members are joined. Span is the distance between the outsides of the walls covered by a roof. Rise is the vertical distance or height of the roof. The overhang is the horizontal distance covered by the roof outside the walls. The tail is the portion of the top chord that is outside the walls. The slope of a roof is a way of indicating how steep the roof is. The slope of a roof is usually given as the number of inches of rise per foot of run. This is called unit rise. Another way of stating the steepness of a roof is pitch. Pitch is the rise of the roof divided by the span and is stated as a fraction. In writing unit rise, the slope is given as the number of inches of rise for every 12 inches of run. The rise per foot of run is given on drawings with the symbol of a triangle. The horizontal leg of this symbol represents the run. The vertical leg represents the rise, and notice that this figure illustrates two roof slopes. These slopes are written as 10 in 12 and 5 in 12. By planning the slope and overhang of the roof, the designer can minimize the amount of scrap material that is generated in its construction. The ideal dimensions for a roof section would be in 2-foot increments. Most roof framing is spaced either 16 inches on center or 2 feet on center. A roof that is multiples of 2 feet in length and width, ridge to eave, will not require extra framing if it is framed 2 feet on centers. Also, the roof decking that is usually sheets of 4-foot wide material will have only 2-foot wide scraps if the width of the roof is a multiple of 2 feet. The 2-foot scraps can usually be used on the next row of decking. Steeper roofs have more roof area than do low-sloped roofs. The designer can make the roof width fit the 2-foot grid by adjusting the slope of the roof. When the dimensions are given for a run of other than 12 feet, the rise per foot of run can be calculated. Divide 12 by the actual run to find the proper ratio of rise. Multiply this result by the actual rise to find the rise per foot of run. For example, if the run is 14 feet 6 inches and the rise is 5 feet, what is the rise per foot of run? 12 divided by 14 feet 6 inch, 14.5 feet, equals 0.83. Multiply this rise per foot of run times the total rise of the roof. 0.83 times 5 equals 4.15. The unit rise of this roof is approximately 4 1/8 inches, close enough to 4 that rafter calculations can be based on 4 and 12. Although most modern roof frames are built with trusses, it is valuable to know something about rafter-framed roofs, because some special situations call for rafters to be cut and installed on the site. The run is the vertical distance covered by one rafter. Run does not include any part of the rafter that extends beyond the wall. On a common two-sided roof with both sides having the same pitch, the run is 1/2 the span. The measuring line is an imaginary line along which all roof dimensions are taken. The measuring line of a rafter is a line parallel to its edges and passing through the deepest part of the bird's mouth. A bird's mouth is a notch cut in the lower edge of the rafter to fit around the top of the wall. The ridge board is the horizontal member to which the upper ends of the rafters are connected. Roof color matters. Lighter color roofs generally reflect more of the sun's energy than do darker colored roofs. Also, smooth metal reflects more than does the rough surface of composition shingles. By reducing the amount of the sun's heat that is absorbed by the roof covering, the air conditioning load of the building can be reduced. Roof trusses. After completing this unit, you will be able to perform the following tasks. Find information about trusses on plans, elevations, and sections. Identify the appropriate truss engineering drawing for each truss in a roof frame. Find key information on a truss engineering drawing. Truss information on drawings. The roof is designed to support weight, withstand weather, and give protection to the spaces below. In most roofs, the frame is made up primarily of trusses. However, some special framing situations call for rafters. Designing trusses to withstand all the stresses that can be placed on them by wind or snow or both requires the skills of an engineer. Generally, the architect or designer who designs the house has some idea of what size and type of trusses will be required. The plans and elevations for the building show a lot of information about the trusses. The pitch of the roof can be seen in the building elevations. Section views through the building show trusses, but the truss shown in a section might not be the truss the engineer designs. Notice that a note in the truss area in this figure says the city and PE, which stands for Professional Engineer. Approved roof trusses at 24 inches OC and gives load information that the truss designer will need. This note indicates that the trusses will be designed by a professional engineer PE, who is licensed in this city, and that they will be spaced 24 inches from the center line of one truss to the center line of the next truss. The snow accumulation may weigh up to 40 pounds per square foot on level ground, and the wind might be up to 115 miles per hour. The roof framing shown on the drawing is only an outline to give the truss designer the information that is needed to design the trusses. Truss engineering drawings. To see what the engineered trusses are, refer to the truss drawings from the engineer. These usually include a delivery sheet showing all the types of trusses used in the building. This sheet usually shows the following information. Profile, a small drawing showing the basic shape of the truss. Quantity, number of each type of truss needed for the building. Truss ID, the engineer's letter/number designation for that truss type. Span, the distance between the outside walls the truss will cover. Truss type, some trusses are referred to as piggyback trusses. Large trusses can be too large to transport to the construction site, so they are delivered in two parts. The top of the main truss is flat, so the piggyback truss can be applied to it after it is in place. Slope or pitch, the example here shows slope or the unit rise of the roof. LOH, left overhang, the amount of the top chord that must extend beyond the building wall. ROH, right overhang the amount of the top chord that must extend beyond the building wall. The packet of engineering drawings usually includes a truss layout plan like the one shown in this figure. This plan shows the position of each truss on the building, with a label to indicate the truss ID. If you know from where in the building the section view is taken, you can find truss on the truss layout. The section view is labeled as A5, so look at the second floor plan to see where the cut was made to take section A5. The section was cut through the master bedroom and master bath, which are on the left side of the house. Looking at the front building elevations in the figure, you can see that this has a small gable on the roof above the main entrance. Refer to the truss layout at previous figure to see how this gable is to be framed. There is a triangle with 3 trusses, V2, V1, and T2GE. The main roof trusses T1A runs beneath the trusses for the small gable, so the small trusses are applied on the main trusses after the main trusses are secured in place. Refer to the truss delivery sheet to see what the trusses look like and how big they are. V1 and V2 are the last 2 trusses on the delivery sheet, and T2GE is the 4th truss from the bottom. The truss engineering drawings are detailed drawings for each truss type. Truss T1A is shown in the figure. The truss detail includes a drawing of the truss and all the engineering data required to build the truss. Carpenters do not usually build trusses, but the same packet of engineering drawings that go to the site with the trusses is also used in the truss shop to build the trusses. It is very important for the carpenter to read all the information on the detail, even though it might not all be needed to set the trusses on the building. For example, in some applications, the engineer will call for the trusses to be applied in 2-ply or 3-ply. If the trusses are plied, they are fastened together, face to face, so that all the truss members are joined in 2 or 3 layers. In this case, the ply is shown as 1 in the box at the top of the detail sheet. The last sheet in this packet of truss engineering drawings is an explanation of symbols, numbering, and general notes. Gable ends. A roof gable is the triangle formed at the end of the roof by the 2 top chords of the truss and its bottom chord. The roof framing at a gable end must include studs, so there will be a place to attach whatever sheathing and siding are to be applied. A gable end truss is used for this. When an overhang is needed on the gable end, it can be built as part of the gable end truss. Common rafters. After completing this unit, you will be able to perform the following tasks. Find information about roof construction on drawings. Calculate the length of common rafters. Calculate the length of rafter tails when overhang is given. Roof construction. In a common frame roof, the rafters, ridge board, and collar ties are the structural members. They are sized and spaced to support the weight of the roof itself plus any snow or wind that can be expected. The protection from weather is provided by sheathing or roof decking and roofing material. The size and spacing of the rafters vary depending on their length, pitch, and load, weight they must support, and are specified in tables R 802.5.11 through R 802.5.18 of the International Residential Code. If the rafters span a great distance or are spaced far apart, they must be deep to support their load. The vertical dimension of rafters and joists is called depth. The size and spacing of the rafters are shown on the section view. The ridge board is also usually shown on a section view. The ridge board should be made of stock 2 inches deeper than the rafters. The greater depth is needed because an angled cut across the rafters is longer than a square cut across the rafters. When the roof framing is complicated, a separate roof framing plan may be included. Roof framing plans are used only to show the general arrangement of the framing. Therefore, unless specific dimensions are included, framing plans should not be relied upon for the lengths of the framing members. The roof frame may also include collar ties. Collar ties are usually made of 1 inch, nominal thickness, lumber. They are normally included on every second or third pair of rafters. This information should be shown on the roof section if collar ties are planned. The slope of the roof may be shown on any section view. Size. Slope is usually also shown on the building elevations. Roof covering. The most Common roof decking materials for houses are plywood and oriented strand board, OSB. However, post and beam construction, where the extra strength is needed in the distance between the rafters, dimensional lumber is used for the roof deck. The material used section is often chosen for its architectural style. Some of the most common materials are shingles, wood shingles, and terracotta or metal tiles. The material to be used is shown on the section view of the roof and usually on the building elevations. The roofing should be applied over a layer of roofing underlayment. The underlayment is a membrane that prevents the chemicals in roofing materials from leaking onto the roof decking. Underlayment also provides an additional layer of waterproofing. There are three types of commonly used roofing underlayment: asphalt saturated film, rubberized underlayment, and non-synthetic underlayment, polypropylene or polyethylene. Asphalt roofing materials, including felt and shingles, are sold by their weight per 100 square feet of coverage. 100 square feet of roof is called a square. If enough shingles to cover 1 square weigh 235 pounds, they are called 235-pound shingles. Asphalt saturated felt underlayment is typically 15 pounds or 30 pounds weight. Raised heel rafters and trusses can be used to make more room for insulation and proper ventilation at the edge of the roof. In raised heel rafter construction, the ceiling joists rest on the top plate with a joist header capping their ends. A separate plate is nailed on top of the joists and header, so the bird's mouth of the rafters rests on this upper plate. In this way, the full depth of the joist is available for insulation right up to the edge of the roof. Finding the length of common rafters. Carpenters use a rafter table to find the length of rafters. These tables are available in handbooks and are printed on the face of a framing square. To find the length of a common rafter, you must know the run of the rafter and its rise per foot of run. The run can be found on the floor plan of the building. The rise per foot of run is shown on the building elevations. The length of the common rafter is then found by following these steps. Step 1. Find the number of inches of rise per foot of run at the top of the table. These numbers are the regular graduations on the square. Step 2. Under this number, find the length of the rafter per foot of run. A space between the numbers indicates a decimal point. Step 3. Multiply the length of the common rafter per foot of run, the number found in Step 2, by the number of feet of run. Step 4. Add the length of the tail, and subtract 1/2 the thickness of the ridge board. The result is the length of the common rafter as measured along the measuring line. Note, if the overhang is given on the working drawings, it can be added to the run of the rafter instead of adding the length of the tail. Shed roof framing. Most of the lake house has shed roof construction. That is, the common rafters cover the full span of the area they cover in a single slope. To find the length of shed rafters, treat the entire span of the rafters as run. For example, the total width of the garage is 13 feet 9 inch. There is no overhang on either side of the garage, so the span of the garage rafters is 13 feet 9 inch. Use 13 feet 9 inch, or 13.75 feet, as the run in calculating the length of common rafters. Where shed rafters butt against a wall or other vertical surface, the drawings should include a detail to show how they are fastened. Shows 3 methods of fastening rafters to a vertical surface. It is often necessary to frame openings in the roof. Where chimneys, skylights, or other features require openings through the rafters, headers and double framing members are used. This method of framing openings is similar to that used in floor framing. Hip and valley framing. After completing this unit, you will be able to perform the following tasks. Calculate the length of hip rafters. Calculate the length of valley rafters. Calculate the length of hip and valley jack rafters. Hip rafters. Hip rafters run from the corner of the building to the ridge at a 45 degrees angle. The length of hip rafters can be found by using a table found on most framing squares. The second line of this table is used to calculate the length of hip rafters. This table is based on the unit run and rise method for finding the length of common rafters, explained in Unit 22. To calculate the length of a hip rafter, you must know the run of the common rafters in the roof and the unit rise of the roof. The length of the hip rafters is then found by using the table for length of hip and valley rafters in the same way the table for the length of common rafters is used in Unit 22. Step 1. Find the unit rise, number of inches of rise per foot of run, at the top of the table. These numbers are the regular graduations on the square. Step 2. Under this number, find the length of the hip rafter per foot of run of the common rafters. Step 3. Multiply the length of the hip rafter per foot of common rafter run, the number found in Step 2, by the number of feet of run of the common rafters, 1/2 the width of the building. Step 4. Subtract the ridge allowance. Because the hip rafter meets the ridge board at a 45 degrees angle, the ridge allowance is 1/2 the 45 degrees thickness of the ridge board. The 45 degrees thickness is the length of a 45 degrees line across the thickness of the ridge board. The 45 degrees thickness of a 1/2 inch, 2-inch nominal, ridge board is 2 1/8 inches. Therefore, the ridge allowance for a hip rafter on a 1/2 inch ridge board is 1 1/16 inch. Note: if the hip rafter includes an overhang, add the overhang of the common rafters to the run of the common rafters. Example: find the length of a hip rafter for the roof. 1. Rise per foot of run is 40 inch. 2. Length of hip rafter per foot of common rafter run is 17.44 inch. 3. Common rafter run including overhang is 16 inch. 4. 16 times 17.44 inch equal to 279.04 inch. 5. Subtract 1 1/16 ridge allowance, 279 1/16 inch minus 1 1/16 inch equal to 278 inches. The rafters that butt against the hip rafter are called hip jack rafters. They are cut at an angle. This angled cut produces a surface that is longer than the width of the lumber from which the rafter is cut. Therefore, the hip rafters are sometimes made of wider lumber than the common rafters and jack rafters. Valley rafters. The line where two pitched roofs meet is called a valley. The rafter that follows the valley is a valley rafter. It is most common for both roofs to have the same pitch. This results in the valley rafter being at a 45 degrees angle with both ridges the same angle as a hip rafter. Because the angles of the hip and valley rafters are the same and the pitch is the same table can be used to compute their lengths. All steps of the procedure given earlier for hip rafters can be followed to find the length of valley rafters. However, the valley rafters often have no tail even though the roof has an overhang. In this case, the total length of the valley rafters is computed on the basis of the run of the common rafters excluding the overhang. When both roofs have the same span and rise, the valley extends from the eave to the ridge. When one roof has a greater span than the other, the valley does not reach the ridge. In this case, the valley is framed in one of two ways. One valley rafter can extend to the ridge, and the other can butt against the first. The other method is to install a common rafter on the wider roof in line with the ridge of the narrower roof. Both valley rafters can then butt against this common rafter. The length of the valley rafters is based on the run of the common rafters that have their upper ridge ends at the same level as the valley rafter. In other words, when the long and short valley rafters are used, the length of the long valley rafter is based on the run of the common rafters in the wider roof. The length of the short valley rafter is based on the run of the common rafters in the narrower roof. When both valley rafters butt against a common rafter of a higher roof, their lengths are based on the run of the common rafters in the narrower roof. The most important function of a roof is to prevent water from entering the structure. One area where leaks sometimes occur is in valleys. If the valley flashing is not wide enough for the pitch of the roof, wind-blown water may be forced under the roof covering and run beneath the flashing. Most roofers also apply a self-adhering ice and water barrier to the valley area before installing the flashing. The ice and water barrier provides excellent additional protection against leaks in the valley. Jack rafters. Rafters that extend from the wall plate to a hip rafter are called hip jack rafters. Those that extend from a valley rafter to the ridge board are called valley jack rafters. The third and fourth lines of the rafter table on most framing squares are used to calculate the length of jack rafters. The length of each jack rafter in a roof varies from the length of the one next to it by the same amount. The amount of this variance depends on the spacing of the rafters and the pitch of the roof. The third line of the rafter table is used when the rafters are spaced 16 inches OC. The fourth line is used when they are spaced 24 inches OC. As with the other lines of the rafter table, the inch numerals at the top of the square are used to indicate the unit rise of the roof. For example, if a roof has a 6 in 12 slope and the roof framing is 16 inches OC, the difference in the length of jack rafters is 17 and 7/8 inches. The first jack rafter should be a full space, 16 inches or 24 inches, from the bottom of the hip or the top of the valley. Therefore, the first jack rafter should be the length shown on the rafter table. The length of the tail must be added to the theoretical length from the table. The length of the tail on hip jacks is the same as the length of the tail on common rafters. Therefore, the length of the tail can be found by using the table for the length of common rafters. Simply treat the tail as a very short common rafter. If the overhang is not in even feet, divide the length of common rafter per foot of run on the table by 12. This gives you the length of the common rafter or jack rafter tail per inch of run. Example: find the length of the tails of the jack rafters. 1. Unit rise per foot of run is 4 inches. 2. Length of common rafter per foot of run is 12.65 inches. 3. Length of common rafter per inch run is 12.65 inches divided by 12 equal to 1.05 inches. 4. Run of rafter tail, overhung, is 8 inches. 5. Length of rafter tail equal to 8 times 1.05 inches equal 8.4 inches, approximately 8 and 7/16 inches. Hip jack rafters are also shortened at the top to allow for the thickness of the hip rafter they butt against. This allowance is 1/2 the 45 degrees thickness of the hip rafter. Valley jack rafters are shortened at the bottom to allow for the thickness of the valley rafter. This allowance is 1/2 the 45 degrees thickness of the valley rafter. The valley jack rafters are also shortened at the top to allow for the thickness of the ridge board. The ridge board allowance for valley jacks is the same as the ridge board allowance for common rafters, 1/2 the actual thickness of the ridge board. Example: find the length of the hip jack rafters A, B, and C, and the valley jack rafters D, E, and F in previous picture. Here are calculations for hip jack rafters and valley jack rafters.